Okay, once again, you just type your USN because so that there will be no loss for your attendance. Okay, so just type your USN. Okay, yeah. So we are going with respect to your noisy channel. Noiseless, we have seen it with respect to Nyquist. So noisy channel, whenever it comes, one or more mathematician by the name called as Shannon, he has given a particular formula for calculating the maximum bit rate. So maximum bit rate, according to him, will be equal to, that is capacity. He says C. That's why C has been named. Is equal to the bandwidth, that is B, multiplied by logarithmic of 1 plus signal to noise ratio. So with respect to the base 2. So bandwidth into logarithmic of 1 plus SNR to the base 2 is the formula that we'll be using. So what is this B? B is nothing but bandwidth, which will be measured in hertz itself. And this SNR is nothing but signal to noise ratio. What is signal to noise ratio? Average power at the signal level divided by average noise power. If you just give it, then it will be nothing but your signal to noise ratio. So with respect to this only, we are just calculating it. And there is one more particular statement that has been made here. No matter how many levels we use for signal. That means with respect to your particular Nyquist, we were following 2 times the maximum bit rate that you can transfer as 2 times the bandwidth logarithmic of level L, the signal level. How many levels that you will be having depending on that it was given. So here, no need to consider that particular signal level. So intuition is if noise is bigger, then signal level cannot be too bigger in order to correctly read received signal. If the noise is bigger, then signal level cannot be bigger. That is with respect to the amplitude I'm talking about. So if you are getting confused, we'll just go back to the previous slides where we just had a discussion with respect to this noise, right? So this is what we talk about with respect to your ideal signal, large SNR, which is highly impossible. That means noise will be completely flattened. That is no amplitude at all. That is very, it is not possible at all. Suppose if you take this particular thing, you can apply Shannon as well as Nyquist also. There is no problem. If they have asked how much is the capacity, then go with the Shannon capacity. And if they say noiseless channel, go with the Nyquist particular theorem to apply or to calculate the maximum data or maximum bit rate. Understanding it? So that's what it is all about. So here with respect to this, they are talking about this one. The statement what they have made is with respect to this. Signal is very low. That is, the amplitude is not reachable at all. Whereas noise amplitude is very much higher. Then this noise will be overtaken. That's what they are saying it with respect to your noisy channels. Okay, so that is the meaning of this particular statement. We'll just go back and go to the next one. Consider an extremely noisy channel in which the value of the signal to noise ratio is almost zero. In other words, the noise is so strong that the signal is fainted. So when SNR will be zero, when the signal strength, when the signal power is zero, noise power is maximum. Zero by anything is zero itself. So that's what they are saying. For this channel, find the capacity. This is a noisy, and they are saying that you need to find the capacity. The maximum bit rate only you need to calculate. How to calculate it? We know that the bandwidth should be given. The bandwidth B multiplied by logarithmic of 1 plus SNR to the base 10. So with respect to that formula, if you are just applying it, means what will be the thing? So B into logarithmic of 1 plus 0 to the base 2. So logarithmic of 1 to the base 2 is always 0. So with respect to this, the entire capacity will be 0. So if the signal is not at all there, then the capacity will also be 0 itself. That is what the meaning is. Understood? Are you getting this? So this is what your Shannon will be trying to explain you. Okay, that's what I just said some words, right? The same thing. Now we can calculate the theoretical highest bit rate of a regular telephone line. A telephone line normally has a bandwidth of 3000 hertz or 3 kilohertz, whatever you want, you can just imagine that. The signal to noise ratio is usually 3160. So they have given SNR also. For this channel, the capacity is calculated as C is equal to, what is the formula? Capacity, once you are calculating it, is nothing but logarithmic of 1 plus SNR to the base 2. Logarithmic of 1 plus SNR to the base 2, if you substitute, what is the bandwidth? 3000. What is the SNR? SNR value, they have given it as signal to noise ratio is usually 3162. 3162 plus 1 is 3163. So 3000 into logarithmic of 3163 to the base 2. If you just calculate it, you need to calculate this separately first. Logarithmic of 3163 to the base 2. You know how to calculate with respect to your calculator if you use it. So if you just give that particular value, this is what the value you'll be getting it. So once you multiply with 3000, it is approximately 34 or approximately you can say 35 kbps is the capacity that you can transmit with respect to your Shannon capacity. Understood? That's all. What that particular this capacity means, this capacity is nothing but that much amount of data you can travel in that particular transmission medium. That means the bandwidth based on that, you can travel 35 kbps or 35 kilobits you can transmit in 1 second. That's what the meaning is. In order to improve the more the capacity, if you want to if you want to transfer more data means, that is, if you want to increase the capacity means, you need to increase either the bandwidth, that is capacity of bandwidth 3000 to 6000. If you increase it, then it will be increased, or else you can improve the signal to noise ratio. So signal is very much higher when compared to noise. With respect to this, you can just get back the result for it. So that's what they are saying it with respect to this particular statement. Next one is, the signal to noise ratio is often given in decibels. So in decibels, you need to calculate it. So keep one thing in your head, whenever they have asked you to calculate in decibels, it should be in terms of 10 times of logarithmic of that particular value to the base 10. So that's what they are doing it over here also. So SNR dB is equal to 10 times of logarithmic of SNR to the base 10 will give you the answer for it. So what is this particular SNR now? SNR will be equal to 10 to the power of 36. What is this 36 now? Where it has been come from 36. 36 is nothing but here decibels that has been given. So 36 to the base 10. That's what they are giving it. So 36 SNR dB is there. So SNR dB value is 36 means. So if you are applying with respect to this means, you need to apply the anti-log. 10 logarithmic of SNR to the base 10 is equal to 36 dB. So this is nothing but here SNR is equal to 10 to the power of 36. That is here 36 is this one divided by this particular value 10. So whatever the value comes, that is nothing but your SNR. If you calculate, if you just apply this with respect to your capacity, then your capacity will be calculated. The same formula, there is no change in it. Okay. Only thing is, if it is given in decibels, then you need to convert it back to the SNR. Okay. You cannot express in decibels with respect to your Shannon capacity. That's what they have given. Are you getting it? Suppose if I want to express that particular thing in the decibels itself, then how to do it? For that, for practical purposes, that is in the practical scenario, we think that always SNR will be always taken care with respect to whatever the 1 plus SNR is there, no, it will be neglected. This one can be neglected with respect to the maximum number of or highest SNR. That is 100 is the SNR value means 1 can be neglected. 101, 100, both are giving the same thing. So that's why you can neglect that. So with respect to that, when the SNR is high, your SNR plus 1 will be equal to, will same as SNR itself. So with respect to this, if I apply this particular thing in our formula, then your entire capacity with respect to your theoretical capacity, whatever you are saying it will be reduced to this particular formula, bandwidth into SNR dB to the divided by 3. Why it is 3? Why can't it is 2? What is the formula that we have for SNR dB? SNR dB will be equal to 10 to the power 10 into logarithmic of SNR to the base 10, right? So with respect to that, if you move on to the next slide, see capacity is calculated as B into logarithmic of 1 plus SNR to the base 2. This is the capacity. So now this one you are changing that as SNR. So we know that in dB, in terms of that, I need to express it, right? So SNR dB is equal to 10 into logarithmic of SNR to the base 10. This is what I was talking about. So now if you just reconsider this particular thing, if you want to calculate the SNR, how it will be? SNR is equal to 10 to the power of SNR dB divided by 10, right? There we had SNR dB as some 3 decibels or something like that. So there's based on that particular answer, we have just calculated it. So now it is SNR dB to the base 10. So this one I will just substitute in this particular SNR value. Now your capacity becomes bandwidth multiplied by logarithmic of 10 to the base 10 to the power of SNR dB divided by 10. In terms of SNR dB decibels, I need to express it. So that's why. Understanding it. So we cannot leave it over here itself. We'll be just moving it one step forward. So what this particular thing is saying is, so your SNR dB, whatever it comes with respect to the power, it is nothing but the constant according to the logarithmic property. So based on that particular property, what I'm doing is I'm just giving this particular to the power of whatever is there. It is a constant value, so it cannot be changed. So based on that, it will be taken out from the logarithmic value. So B into SNR dB divided by 10 multiplied by log of 10 to the base 2. Log of 10 to the base 2, if you calculate, means it is approximately, it will be 3.322. That is the value that you will be getting it. If you multiply this, so now I'll just take 3 is there, right? 3.3 is there, right? I'll just take it as 3 itself. I'll round it off to the 3 itself. So based on that particular thing, now our particular capacity becomes 3 into bandwidth into SNR dB divided by 10. So 3 by 10, if you just want to express, means it is 1/3 of that entire particular scenario. Out of 10, 3 divided by 10 means 1/3 of the value. So based on that, your SNR dB by 3 into B will be the answer for it. This is how you'll be calculating the capacity if you are given the SNR dB. If I apply the SNR dB contents over here itself, then the answer will be something like this. So what is SNR dB? 36 dB is there, right? So 36 by 3 into bandwidth, if you just calculate, then it will become the capacity. Capacity is 24 Mbps with respect to this. Just check out with respect to previously calculated one, both are one and the same. There is no change. So if you have given the decibels, you can directly go with applying bandwidth into SNR dB divided by 3. Otherwise, bandwidth into logarithmic of 1 plus SNR to the base 10. That's what the formula that you need to use. So this is for your capacity calculation. One more thing is that we'll just we have a channel with a 1 megahertz bandwidth, and the SNR for this channel is 63. SNR is given, so bandwidth is given. So what are the approximate bit rate and signal level? Signal level, if you want to calculate, means you need to go with the Nyquist theorem. Whereas approximate bit rate, if you want to calculate, means you can calculate with respect to your capacity. So with respect to your capacity, you can just have this particular thing. So Shannon formula, what it says, upper limit with respect to that, they are saying it. So with respect to that, C is equal to bandwidth multiplied by logarithmic of 1 plus SNR to the base 2. So this will give you the answer for your capacity that it can allow. So total capacity is 6 Mbps. In that 6 Mbps, how much you will be staying or how much you will be just using it for your bandwidth, and how much you'll be using it for your bits to be transmitted. Depending on that, you can calculate the signal level. So based on that, you need to use both the things. First, you need to use this particular formula to calculate the capacity. So signal level, if you want to calculate, means we know one thing: maximum bit rate is equal to 2 times of bandwidth multiplied by what is the formula for it? Logarithmic of L to the base 2. Why 2? Only 2 bits you'll be transmitting, whether it is high or low, based on that. Understanding it? So it's a binary logarithmic. So that is what they will be saying it with respect to your calculation of the levels. So based on that, you can just calculate the L value. Substitute this particular capacity now. So you'll get the answer for that particular thing over there. So that's what it is with respect to your band. So with respect to your level, calculating the signal level. Okay. So what is this Shannon capacity will be doing and Nyquist formula will be doing? First and the foremost thing is Nyquist theorem will be applied for noiseless channel. Where the noise is very much low, there you can apply it. Whereas Shannon capacity will give you the upper limit, that is the capacity, the amount of bits that can be transmitted in that particular transmission medium. So that's what it will be giving you. So Shannon capacity always provides you with respect to the noise channel, that too upper limit will be taken into consideration, whereas Nyquist formula tells you how many signal levels can be we need for calculating the or for sending the data bits. Understanding it? Signal levels, Nyquist formula. Whereas upper limit, Shannon capacity. Keep this in your head. Noisy, Shannon capacity. Noiseless, Nyquist theorem. So this is the thing that we need to just look into it. The last part of your particular first module, we are just into it. That is called as one is performance. What is this performance is all about? So what about the data? So previously, when you all joined, I just disconnected the call, once again logged in. Why this particular thing? Because of so many problems. That is, not only we are using the Zoom app, many other people will be using it. So a lot of things that need to be done, or the server need to be handled properly, because so many threads will be available. Many across the globe, many will be accessing this particular type of application. Means then you think about the capacity. So that your bandwidth, it should be improved. So if you are using the mobile data, if it guarantees you to give the 10 Mbps line, maybe with respect to the same particular network, many others may be also using the same particular application. So with respect to or different applications, whatever they want, so they may be using it. So depending on the usage, your particular bandwidth will be reduced. Suppose you have, they will be giving you a guarantee that 10 Mbps line will be given, or 10 Mbps of data, you can just use it with respect to the connection that you have taken it. So with respect to one particular network vendor only, we'll just see it. That is with respect to your mobile provider, like service providers like Airtel or Jio, whatever you want to just imagine, you can imagine it. So in the house, there is only one connection, and out of that particular one connection, the rest of them also should be shared. So 5 members are there. So 10 Mbps line is given for one particular fellow. If you make a hotspot, then your capacity, if one more particular connection is connected, means it will be reduced to 2. That means 5 Mbps for your particular line, 5 Mbps for other particular line. So you will be never getting 5 Mbps directly. So in that 5 Mbps, once again, there will be a reduction. Why? Because of this particular noise, because of this performance in the network that is going on. So it may be due to the latency, or between based on the bandwidth also. Latency will just come to know what is that. In the bracket, they have given it as delay. You can just try to see this particular word, delay. You will be coming to know what is that particular. Okay, so the delay is based on this particular performance itself. So maybe reduced. So you may get hardly 3.5 Mbps of line. That's it. You use it. So remaining 1.5 will be always dropped because of so many network issues. So think about it. If I have 5 other, if I want to share the same particular link with respect to remaining 4 of them, then your complete bandwidth will be reduced. So complete bandwidth reduction means bandwidth is nothing but number of bits that it can transmit in that particular channel. If that is reduced, then your total amount of whatever the delay we are talking about, that will be very much higher. So more the bandwidth, more the data can transmit. It is as good as saying you have a one particular box which is having the width as somewhere around 100 meters. 100-meter length means with respect to that, how many amount of data that you can transmit, you can just transmit in that particular area. So bandwidth is more means you'll be receiving more packets. More packets means the speed will be high. So that is what it will be saying it. Speed is always referred to as bandwidth in our particular thing. That is very important thing with respect to your performance. Network performance based on that. So bandwidth is one particular thing where we are just looking into it. So the second one is throughput. Okay, I have a bandwidth of 100. That's what I said. 5 Mbps is given. In that particular 5 Mbps, whole 5 Mbps cannot be used. In that, only 3.5 Mbps is used. That means whatever you have sent, you have received at the particular receiver properly. Remaining 1.5 Mbps is lost. It is of no use. You have not considered that particular area itself. That means The throughput of that particular thing is 1.5. Very simple example I'll give you. All of you, how many are there? 54 have been participated now. After listening to my lecturing today, if I give a particular test, quiz, uh, all of you will enter to that particular quiz. You'll answer the questions. You'll do everything. Yes, fine. Now, due to some reason, few of them, that is only out of 54, 52 have participated in the quiz. 2 persons have not participated because of the network issue. Since we are doing the distance learning, so based on that, I'm just talking about it. So 2 of them will never get a chance to connect to that particular quiz. Then what happens? So my ultimate throughput is 52 itself, because out of 54 I have tried. So out of 54, only 52 have taken it and 52 have completed that particular task. So instead of, see, many of the times I'll be seeing this. There will be an increase and decrease with respect to the number of participants. It is purely depending on your network bandwidth. So based on that, I need to decide. Okay, 58 students are the admins. Out of them, 54 have been attended. So that means my throughput is never 100%. It is 54 divided by 58. Whatever the thing is that much. That means how many have been coming here, how many have been listening to my lecturing, how many are active during that particular period, that is counting more. So that is nothing but your throughput is all about. Latency is delay. Now, my voice may be delayed at your end. Whenever I'm talking in a normal way. So according to me, it is visible or it is audible to all of you. This is what I'm just giving it. But ultimately, out of 54, 52 members are receiving my particular audio properly. I'm just giving you a real-time example. Yesterday or day before yesterday, one person was chatting with me saying that audio is not audible, or your voice is not clear enough to listen to it. So it is not clear enough, or it has not been audible itself. Now, there may be two chances. The microphone that they have connected may have been not properly connected. First thing is. Second thing is, the voice may be lowered at that particular end. So this is the 2 points that you can have it. So based on that, whatever the things that I have said that has been missed over that, understanding it. So this is the delay that they will be following it, or I'll be always pausing before starting my class. 5 minutes I'll pause it. Why? I'm just asking everybody to enter to this particular meeting. So for that particular duration, I'm just giving some time. So that time depends on the sender, that is, I'm the host. I'm just giving you some time to settle down to the class, inside the class. Once that is done, the next thing is how many particular thing, or how well you have understood, or how well you have uh, got the things with respect to whatever the things that I'm delivering in the class. For that particular thing, one more time will be wasted. So like that, n number of things will be constituted. So you may be delayed in getting it. That is called as queuing time. So you will be in the queue waiting for somebody else to log in. So which is nothing but I'll be not hosting the meeting. I have delayed by 5 minutes, means you will be waiting there. So that is nothing but queuing time. So you'll be waiting in that particular area. Once the host comes, then you will be logged in automatically. So this happens. This is called as latency, we'll call it as. One by one, we'll just see it. Bandwidth, I'll not talk about this much. There are two particular statements given over there in the screen. It is easy for you to get it also. One definition for your bandwidth is in terms of hertz. It is nothing but range of frequencies in a composite signal, or range of frequencies that a channel can pass. That means the low pass or band pass or high pass, in that how many frequencies can be passed, that is what they will be saying it, that is the bandwidth. Next one is with respect to a digital signal, that is bit rate. So how many bits that you can transmit at a time per second, how many bits that you can transmit in a transmission channel, that's nothing but your bandwidth. So based on this, your particular entire scenario comes into picture. Network performance. So one particular example has been given. I'll not touch this particular example because it's already well known to us. So under this noiseless condition, this is what the formula that we'll be giving it. So if it is a noisy channel, then B into logarithmic of 1 plus SNR to the base 10. Understanding it? That's what it is. Throughput. How fast? your bits per second of data can actually send. So it is nothing but 54 members have taken the exam. Out of that, how many has been passed? That is nothing but your throughput. Got it now? It's very simple to easily understandable. So throughput is nothing but how many has been passed. How many have been failed? It is nothing. No need to consider it. So that's what I said. Out of five particular 5 Mbps of data, if you are dividing it among two, out of 10 Mbps, two particular division, if you are making it, whole 5 Mbps or whole 10 Mbps will not be given. So there will be a breakage of that particular thing. So if you are saying it with respect to your partition among, how many, what is the capacity of your hard disk? If I ask you, some may say 1 TB, some may say 2 TB, some may say 500 GB or something like that. Can you utilize whole thing? No, right? So part of it will be utilized by your RAM. So only it will be giving you to use among 500 GB. So hardly it can be giving you to use 496 or 94 GB of data, or 487 of GB of data. You can just utilize it. Roughly, I'm just giving you an idea. Understand? 1 terabyte, it will not be giving you whole 1 terabyte. Among that, 950 or 970 GB of data, you can just get it over there. So this is the meaning of yeah, throughput. Understanding it? So data congestion causes delay. That's what it says. Data impairment causes data error. This is what it is. So impairment may happen, or congestion. Congestion in the sense there will be a bombardment of the data. Understanding it? You are using the same particular thing. The other person is also using the same particular network provider. Then both the particular data, it will come in the same line. Once it reaches to that particular base station, it will be bombarding. So several particular things, whichever has been bombarded has been lost. So whichever the things that it can go through, only those particular data will be received at the signal. The received at the signal, whatever is that is nothing but your throughput. Understanding it? So that is a simple meaning of your throughput. So for calculating your throughput, there is a formula. So they have given this particular thing. What they have given is work with bandwidth of 10 Mbps. 10 Mbps of bandwidth can pass only an average of 12,000 frames per minute. So 10 Mbps of data, that is bandwidth is 10 Mbps. In that 12,000 frames per minute, you can just transmit the things. But each 12,000 frames per minute, if you want to transmit, with which each frame carrying an average of 10,000 bits. So in that particular 12,000 frames, one frame, if you are taking it, in each frame, it will be having an average of 10,000 bits. So what is the throughput of this particular network? Throughput is calculated by, what is this? How many bits are there in one frame? That one, that is 1,000, multiplied by how many frames you are transmitting? 12,000 frames. So 12,000 frames per minute you are transmitting. So throughput is nothing but 10,000 into 12,000 divided by 60. That is nothing but your 2 Mbps of data you can just utilize for transmitting this 12,000 frames per minute. On an average, each frame consisting of 10,000 bits. Out of 10 Mbps, you are using only 2 Mbps. So 2 Mbps is used out of 10 Mbps. That's it. Understanding it now? The last part is your latency. Latency is a composition of these particular many delays. One is the propagation time, that is starting time. Next one is the transmission time, that is delay in that particular transmission medium. The third one is queuing time. Why queuing time? Receiver is busy, means it need to wait. So for that, queuing time is needed. Last one is after receiving at the receiver, it will not be received at the application layer. It need to wait to process that particular data. So for that, processing delay. So with respect to composition of all these particular things, your latency will be calculated. Understanding it? Propagation time, transmission time, queuing time, processing delay. So how to calculate with respect to your propagation time? So I hardly left out with respect to 1.5 minutes. I'll just try to explain you how this particular thing will be calculated. Normally, propagation time will be calculated with respect to the distance that it need to travel and the speed of that particular data that it can travel. That means distance divided by propagation speed will give you the propagation time. This is at the sender end. Sender should note, depending on this particular thing only, we can segment it. Okay, transmission time. First bit is received, last bit is received. That means first bit is received at the transmission medium from the sender. Last bit is sent out with respect to your transmission medium. First bit is received at the transmission medium. Last bit that has been received at the transmission medium. That is nothing but your transmission time. So based on that, the message size, how much is the size divided by the bandwidth, that is the capacity of that particular channel. So based on that, you'll be calculating the transmission time. Okay, next one is queuing time. This is based on your particular waiting time. So waiting time, it may vary. So from system to system. So end process, if it is busy, means still it becomes active, you need to wait. So that is what it will be saying. Okay, I'll stop here. So 2 more slides was that. So hopefully we'll just continue those 2 particular slides in the next particular class. Okay, so we'll end this particular thing over there. Thank you very much for your patience listening. We'll just continue the rest of the things in the next